and we need to connect this to the switch. So, to set up one small network, a local area network, we require these three components. What are these components? One is the computers. So, say PC1, we can reduce the size, so it becomes easy to PC1, and this is PC2, and this is PC3. So, we want to establish communication between these three computers. Okay. So, this is the media, the one which we are representing here. This is the media. We help the PC to connect to the network with the help of media. So, this media is copper wire. So, we may be using Cat5 cable or Cat6 cable. So, to set up a network, we require end devices like PCs or servers. 2, we require the media. We briefly discussed about the types of media, and then we require a networking device called switch. So, we now go to the next discussion of the third type of network called WAN, wide area network. Wide area network provides connectivity from a local area network in one city to another local area network in another city or another country. So, these three are the different types of networks: local area network within the office, metropolitan area network connecting multiple offices within the same city, and wide area network connecting offices in different cities or different countries. So, this is about the different types of networks. And then we have the third component, that is the networking devices. So, if you see this picture, we have this networking device called switch. So, switch comes under the category called networking devices. So, networking devices under the networking devices, we have 1 switch, 2 router, 3 access point, 4 firewall. So, these are the various components that come under the category called networking devices. So, they help us to set up networks. Networking devices are key devices that allow the network to communicate. So, let us look at another example of how this local area network, this is called as local area network, this is called as LAN, this is one local area network. Suppose we have a similar LAN, let us say we make a small copy of this. So, we have another network. Let us say these two networks are in different places of the same city, and if you want to establish connection between these two networks, we want to establish the connection between this LAN and this LAN. So, this is called as metropolitan area network. So, to set up a connection between two local area networks, we call this as MAN. This is called as MAN, connecting two different networks within the same city. But let us suppose if we have different places in different cities, so we call that as wide area network. So, if you have to connect offices between different cities, we call that as wide area network. So, local area network is within the office, metropolitan area network is connecting offices within the same city, and wide area network is connecting offices in different cities or different countries. So we can give the example of wide area network as internet, or let us say internet is the best example for wide area network. So internet we use every day, so we are using the wide area network which connects all the users across the globe. Okay. So next we have in our discussion the various uses of network. Under the various uses of network, we have been discussing in these examples also, they provide productivity for businesses. They provide productivity for businesses. So let us take an example of a university. So if university wants to conduct some entrance exam for intake of the students for the various courses, so what they do, they publish this information on the university website. So people from all across the world can have access to that information. So they can access the university website, get to know what are the various programs available, what are the various bachelor's courses available, master's courses available, research courses available. So we have a list of various programs that the university is offering and how to enroll into this courses, various courses. From the website you get all the information. So basically it is a productivity. It's enhancing the university's programs to be available for various users across the globe. So the users can in fact make a preliminary inquiry through email and communicate with the staff of the university, and they can also make applications online. So the universities today have developed applications so that the users who are interested to join that particular courses can fill the application form online and submit it, and then wait for the confirmation of the admission. So once we have the confirmation of the admission from the college, you have to pay the fees, and you can pay that online as well. So today there are certain universities offering these programs online as well, so which means you don't have to physically travel to the college, travel to the university. So you can run these various programs with the help of internet. So these are some of the examples that we can look at, and the other examples that we use internet for or network for are examples of a bank. So you can see the banks works only on networks. Today without network there is no way you can send and receive the money, the transactions. So banks backbone, the main backbone for the banks is through networks. Within the branch they use local area network, and when they have to connect the local bank to the headquarters or to the other regions, so the banks also have to follow certain guidelines set by the central bank. So they have a governing body, so they ensure that all the guidelines are set into place, but the basic communication happens through the bank. But banks set up their own network because the bank's data is confidential, so they ensure that there is confidentiality for the data that is exchanged between the branches of the bank, and communication from ATM to the bank, all these are taken care of, but the backbone is the network. So in this session on the basics of networking or networking basics, we have come across the various components that are used to set up a network, and they are categorized into three types, that is end devices, that are personal computers, servers, network printers, and the tabs and the smartphones form the end devices. And the second category we have the media playing an important role for establishing the connectivity between these end devices and servers to a centralized device called networking devices, and these networking devices help facilitate communication between these end devices. So all the three components make up a simple network, and under this network we had discussed about the basics of networking like LAN, local area network, and metropolitan area network, and wide area network. So, this is the very important components that we have discussed about networking, basics of networking. So, let us quickly review that what we have done in this session. So, these are the concepts that we have learned, that is what is a network. We have seen the definition of a network, that is interconnection of two or more end devices is called as a network, and network helps communicate within the local area network or metropolitan area network or wide area network. And to set up this network, we had the three different components, that is end devices, the media and networking devices. Under media, we have discussed about the copper cable, which is very widely used in the local area network, and the fiber cable, which is used both for local area network, for metropolitan area network, as well as for the wide area network. And then wireless communication. So, wireless communication helps for ease of use. So, in the case of local area network, we have two types of local area networks, that is wired local area network with the help of copper cable or fiber cable, or we have wireless local area network. With local area networks of using wireless, there is a drawback, that is you cannot get very high bandwidth, number one. Number two, you have a limitation of distance. There is a device which provides this wireless communication, that is access point. So, the access points have limited range, and they have the restrictions, like if you have the building, in the building you have glass doors or walls. So, the limitation will be very less, the distance cannot be supported too long as the wired cable can provide. With wired cable, you have to be stationary in one place. Suppose you have a connection connected to your PC or laptop, you cannot move around with the help of the cable, but if it is wireless, you have the facility to move around. You can, it's flexible, you can walk into the corridor, you can be walking in the place. If it's in the house, you have Wi-Fi, you have the flexibility to move around and still be connected to the network. That's the advantage of wireless communication, which is not available with the wired communication. With wired communication, you have to sit in one place to use the wired connectivity. But the advantage of wired connectivity is that it has a very high bandwidth. So, end devices like PCs, laptops, we can have Wi-Fi, but not with the help of, not with for servers or not for network printers. So, for network printers and for servers, which are very huge in size, the equipment are very huge in size, so they cannot be having very high bandwidth. So, we have to go with physical connectivity. But there are certain printers which are available with Wi-Fi connectivity. So, you do not have to have a physical cable connected, but it cannot be mobile like we have the laptop or smartphone. They provide a lot of flexibility. Wireless provides a lot of flexibility, whereas wired connectivity provides very high bandwidth. You can have high-end servers have a fiber optic cable connected directly to the server, and then it can provide up to 10 Gbps of bandwidth. So, because there are hundreds of thousands of users access these servers, so they are preferred to have the wired connectivity, and this wired connectivity provides very high bandwidth. And they are also very immune to types of interferences. But whereas Wi-Fi is immune to interferences. Sometimes you have very low signal and you get very low bandwidth. Sometimes when the signal is good, then you have very high bandwidth that is available. So, in the basics of networking, we have to know about the various components that are used to set up the network. Like we have seen in this picture, we have these components, end devices, PCs and servers and printers come here in the part of the end devices. And the second one is the media, it could be copper or fiber. And then the networking devices, you can see these various networking devices. And in the next session, when we discuss about the advanced concepts of networking, we will be discussing about the functions of these equipment and learn more in detail about how this communication actually happens, because we are just showing the physical connectivity, but just having a physical connectivity is not enough for us to send and receive data. So, we will have an advanced topic where we will be discussing about the actual flow of information. So when you request a web page from the browser, and how this information goes out of your computer, how it travels to reach the server, physical server, and then how the reply will come back to you, all this will be discussed in the advanced session about networking. So we have to understand that all these three components set up a network, basics of network. So without any one of these components, it is not easy to communicate. So now let us add a small wireless component to this. I'm going to add a wireless access point to this existing network. So let's suppose this is a wireless access point, and it should have an antenna. So we will keep an antenna here. So wireless access point should have an antenna, and it has an antenna now, and that should be connected to the existing switch. So the wireless access point, it should be connected to the existing switch. Now it allows, let's say, laptop user or a smartphone user. So let's say these are all the smartphones or tabs. So with the help of Wi-Fi, these tabs can now get internet access. So these are, let's say, these are the wireless devices, and these wireless devices, with the help of access point, let me mark it. So this is an access point. So access point helps the wireless devices to communicate with each other. So whether it is in the LAN or whether it is in the home, we have to use these wireless access points for wireless communication. So in the next session, when we discuss about the advanced networking concepts, we will go in detail and have a look at the various components like switch, its functions, router, its functions, access point, its functions, and firewall and its functions as well. So we have to look at the quick overview of this session, that is network, different types of end devices that are part of the network. Then we have the media, different types of media which helps connect the various devices, and then we have the different types of networks, local area network, metropolitan area network, and wide area network, and how they are used, where they are used, and the components required to set up these. We have seen this in the networking devices and their advantages of the benefits that the companies get out of using the networks. Intranet and intranet are the best examples of how organizations benefit. So a bank network is considered as an intranet. All the banks across the country are interconnected, and we call that as intranet. And nobody from outside can access this network. It's exclusive for the bank. Similarly, there are a lot of government networks like Indian Railway Network. So that's exclusively used for the railway employees and railway staff. And under railway network, we have, for example, you want to buy a ticket. So they have a separate network for tickets. We call that as Passenger Reservation Network, PRS. And then we have a different network for administrative purposes. So these are all exclusive to that organization. So similarly, if you look at a state government network, so state government has connectivity to all the districts, to the collector offices, to the various MRO offices. So all these government offices are also interconnected. They are mostly using it for video conferencing. The government officials communicate from the headquarters, from the capital city to all the districts, and keep monitoring various activity. So they are already using these kinds of networks for the benefit of the users. And the organizations, like apart from banks, we have industries. So they all use between the factory and the offices, marketing offices, they connect via this intranet. But the public face of this is the internet, which all of us have access to. With the help of internet, we are able to get information, news, entertainment, banking, business. So you have every activity that is available on the internet, and that's one of the world's biggest network we have discussed earlier. And this network is built based on this concept of the end devices, and these are the components that are part of the internet as well. So we have seen, the end devices could be PCs or servers or laptops, and to connect to internet we are using either through cable connected by the ISP, or it could be via your mobile phone, like you are using 4G internet. So that is also coming under the wireless media. And then the networking devices, though you have a small device at home, we call that as a router, which comes under the category called networking device. And all the ISPs do have this networking equipment which facilitates the communication from your home to the actual destination with the help of these networking devices. So they form a network only with the help of these three components. Though we have discussed about the various kinds of devices under this category, under end devices, under media, we have discussed wireless, under wide we have discussed about fiber and copper, and different types of copper like Cat5, Cat6, Cat5e, and also under fiber we have discussed about the multi-mode fiber and single mode fiber, providing very high bandwidth for long distances. And networking devices, to within a LAN we must have a networking device called switch, which is mandatory, and to connect from one local area network to another local area network, like for example in the case of a wide area network, we must have a router. But at the same time, if you want to protect your network or secure your network from unauthorized access or from internet threats, we have the networking device called firewall, which provides security. So all these end devices, media and networking devices help us to establish a network which is very useful for the organizations and also benefit users for basic productivity purposes, information gathering, exchanging, sharing information, real-time communication. You want to speak with your family or you want to see them who are not physically in your place. We are using video chat, we are using voice communication, we are using Skype, we are using WhatsApp video calling or voice calling. So all these are able to achieve because of the network. So without network our life would not be the same what it is today, and this network helps to establish better productivity for the organizations as well as for the end users. So without a network it is not possible to have this thing. So later in the next session we will be discussing about the advanced concepts of networking and the functions of these various networking devices. Thank you. Hello, welcome to this new session on advanced networking. Just a quick overview of what we have discussed in the networking basics. So in the networking basics session we have discussed about the way a network is designed and a network is built, and the various types of networks and how these networks are set up, and the different components required to set up the network. So in this session today we are going to discuss about the actual communication that happens between the two devices or between the client and the server. So the protocols that are required for communication between the source and the destination, between the user and the server, are divided into two categories. And these are the two important protocols that are available for data communication. But out of these two, only one of them is actually used practically in the networking. So let's explore what these protocols are and how to discuss about these protocols. So in this session we're going to learn about the OSI model and the TCP/IP model. So these are the two data communication models available, and these were developed way back in the 1970s and 1980s. So when the networking was in a very nascent stage, the requirement for establishing communication between the devices required certain protocols. So after a lot of research and development, these protocols evolved, and the actual protocol that is in use today is the TCP/IP protocol. But we are also going to discuss about the OSI layers, because the OSI layer gives us a in detail functionality of how the host, the user, can communicate with the server. So let's start looking at what is this OSI model and how does it work. So OSI stands for Open Systems Interconnection. It is one of the oldest reference model introduced in the year 1984. It consists of 7 independent layers. So each layer will be performing certain tasks. We will be discussing in detail about the functions of each of these 7 layers. And if you look at, it was originally created as a basis for designing a universal set of protocols called the OSI protocol suite. And the OSI model never achieved widespread success. Remember, we had mentioned a little while ago that OSI is not the one which is actually used for data communication, but it is used as a reference model. You can see here, the model became a very useful tool for both education and development to understand the basic communication models. So Open Systems Interconnection was one of the earliest model that was developed for data communication. And if you look at, these are the 7 layers that we are going to discuss now. So these 7 layers consist of application layer called the layer 7, presentation layer called the layer 6, session layer called the layer 5, transport layer called the layer 4, network layer called the layer 3, and data link layer called the layer 2, and finally the physical layer called the layer 1. So it is important to know the order of these layers. We have to follow this specific order, and this is the numbering system. Starts from layer 7 at the top and goes on till layer 1 at the bottom. So we have to now discuss about the functions that each of this layer performs so that network communication is possible. So let us look at the very basis requirement for why this is required. So let us take an example of this computer here. So there's a computer here, there's a PC, and then there's another PC. We want to establish communication between these 2 computers. So we require, yesterday we discussed about the various components required for setting up the network. So this switch will be connected to this PC, and this cable will be connected to another PC. So if you look at, this is the switch, and this is PC1, and this is PC2. So to let this computer communicate from PC1 to PC2, we have to send the data from this computer to this computer. So the data should go from computer 1 or PC1 to the switch, and then switch should forward it to the PC2. So this is what we do. But how does this computer know the data should be sent to that particular computer? So for this data communication, a set of protocols are required, and those protocols are designed in this OSI model and the TCP/IP model. So this first discussion is about the application layer. So the application layer, what does an application layer do? So this layer is acting as an interface between the computer and the server. So basically the users who use a computer to access the resources available on the server has to use the application layer. So what do we mean by an application? So basically application is an example, like for example the web browser. So the web browser we use today to access the web pages or websites is one of the network application. So we have various kinds of browsers available, like Internet Explorer, Google Chrome, Firefox, Safari, etc. So these are the various web browsers available, and these come under the application layer. So examples of application layer include web browser and the FTP, file transfer protocol. So this file transfer protocol is used to exchange data from the client to the server and server to client. Also we have email, which is a very common tool for exchanging information for business purpose, for also personal use. So various applications that we use for email are Outlook, Lotus Domino, Mozilla Thunderbird. These are some of the examples of the applications, and this purpose is for sending and receiving email. And we also have an application called Telnet, and this is a very useful tool for network engineers and system administrators to manage the network efficiently. And this Telnet allows us to connect from the PC to the router or PC to the switch and make changes to the routers or switches configuration. So application layer is what we interact with on a day-to-day basis. So when we open a computer or a laptop or a smartphone, what do we use in those devices? We use applications, whether it be games, or visit accessing the website through browser, or using email application to communicate, or you may be using a bank application for your transactions. So these are the applications which help the user to access the remote servers and network applications. So there are various applications like DNS, DHCP, which are the key applications which work behind the screen. What we use is most of the time the browsers, the FTP, the Telnet, and the various applications that the vendors provide we use. But what happens behind is what we're going to learn and understand the basics of networking. So the next layer we have below the application layer is the presentation layer. And let's look at the features offered by the presentation layer. The presentation layer provides different types of data representation. So if you look at, if we are accessing a web page and this web page provides some information. Let's suppose we go to a website right away. Let's go to www.zoomgroup.com. And what do we get from this web page? So in this web page, you can actually see some text, some information, and you can also see certain images. You can see some images, right? And then we have text. So text and image are the various components that we have in this web page. So these images and text are the different types of data, and we have to represent this in its original format. And this is possible by the presentation layer. So if you look back into the presentation layer, it is representing the different data representation formats. So the text has to be represented in the form of text, image has to be represented in the form of an image, voice have to be represented in the form of voice, and video in the form of video. So this process requires the function called encoding and decoding. So at the server computer or server device will encode the text in the text format, image in the image format, voice and video in this respective formats, and send the information to the destination, which is the user. On the destination device, the computer will decode and display the information in the web browser or the corresponding application. So out of this, if you see, encoding and decoding are mandatory functions on the data. which must be performed for every data packet. But whereas the other functions like encryption and decryption, compression and decompression, these two functions are basically optional. They may be required or they may not be required for all the applications. But what do we mean by encryption and decryption? So if you want to see, the data should not be visible to others, whoever is capturing the data on the network. If you do not want the data to be visible to them, we have to encrypt the data. So when we encrypt the data is not in a readable format, and this data will be transmitted from the source to the destination. On the destination computer, the decryption function will happen and it will convert the unreadable format into the readable format. So the encryption and decryption are normally used for security purposes. Normally we encrypt these passwords. When you are sending and receiving information, you want to log into your email, this password should not be visible. So we have to encrypt these passwords. So this presentation layer takes care of this functionality of encryption and decryption. The additional function it performs is compression and decompression. So if you see, there's a lot of data to be sent to the remote computer. The compression and decompression will help us to ensure that large amounts of data is compressed and sent in quick time. This was a function very widely used in the 80s and 90s because the bandwidth was very expensive. But today, with the globalization of internet and a lot of users accessing the internet, the cost of the bandwidth has come down drastically. So this feature of compression and decompression is not very common as it used to be. So from the application layer, we learned that we use these applications for interaction between the source and the destination, or between the PC and the server. Whereas the presentation layer, which works below the application layer, is responsible for data representation, be it text, image, voice or video. And this information, which started from the application layer, which comes to the presentation layer, which goes down further to the session layer. So let's look at the next layer, which is the session layer. So session layer is the one which is providing the communication between the source and the destination. So what type of communication does it provide? Session establishment. When you want to send data, before you can actually send or receive data, between the source and the destination, there should be a session. Like for example, if you want to call and talk to somebody, you dial the number and the call gets connected. Only when the other person answers, the call is established between you and the other person. So similarly, between the two computers, if you have to send or receive data, the session layer is responsible to establish the connection. So once a connection is established between the source and the destination, then it has to maintain this connection as long as there is data transfer. And once the data transfer is complete from the source to the destination computer, the session layer will disconnect the session or close the connection or terminate the connection. It is as simple as our phone call. We dial the number and the call is established, and then you speak as long as you want to speak, and then once you finish talking to the person, you disconnect the call. So the call gets released. So session establishment, session maintenance and session termination. These are the key functions of the session layer. And to achieve these functions, we have these protocols which are RPC, remote procedure calls, which is available in every network operating system, whether it is Windows 7 or Windows 8 or Windows 10, Windows Server or other operating systems like Linux, Unix, various flavors of Unix and Linux, including the smartphone operating system like Android, Apple, BlackBerry, and all these also have these RPCs involved. Means it's part of the operating system, because to enable communication between the source and the destination, we need to create a session, and the session creation, session maintenance and session termination is performed by this RPC protocol. Apart from this, there are other examples of the session layer, that is SQL protocol. structured query language, and this is very widely used with the database applications. Like you have any database application, they use the SQL application. And in the Apple operating system, we have this protocol called ASP, Apple Talk Session Protocol. Its responsibility is a similar one which we discussed, creating a session between the client and the server and maintaining the session and then closing the session. These are the functions of the session layer. So application, from application the request has come to presentation, and from presentation the request has come to session. So the next layer, which is below the session layer, is called transport layer. And just before we go to the transport layer, the last function that this session layer performs is, during the establishment of the session, every session will be given a unique identity called session ID. So the computer, whichever request it is making from the computer to the remote device, a session ID is maintained for every connection. A unique session ID is maintained for every connection it makes. And then the data goes from the session layer to the transport layer. So let's look at what the transport layer has to do. So this provides, the transport layer provides end-to-end control, meaning when you want to send or receive data, an end-to-end control is required, and that is taken care by the transport layer. And we can see here some of the functions that this transport layer is performing. Identification of service. So transport layer should be able to identify which service is being used. Are we using the web service? Are we using the email service? Are we using the DNS service? Are we using the DHCP service? Like this, there are so many different services available. So these services require to be identified by the transport layer, and this identification of service is done by using the port numbers. So let's look at what are port numbers. So port numbers define the services. So the port numbers start from port number 1 and goes on up to 65,535 port numbers. These many port numbers exist. And these are categorized again into two types of port categories, that is open ports and reserved ports. Open ports are those which come under the range of port number 1 to 49,511, and then the reserved ports are coming from 49,512 up to 65,534. So open ports are those reserved for applications, and it acts as destination port, whereas reserved ports are used by the source, and then it is called as source port. So port numbers are very important and are used for every communication. Suppose you want to access a web page. So the web page is requested from the local browser of the computer. Let's suppose in this example, let's say this is the PC and this is a server. So for the time being, we will consider that this is a server. So if you have to access from the PC to the server, then we need to open the browser and access web server. This is a web server. So from this PC, when we access the web server, the computer will use both source port number and the destination port number. So, the source port number can be any number, random number, and the destination port number will always be a reserved port number. For web services, the port number is 80. The web services, the port number is 80. Web services uses port number 80. So, this is reserved. Okay. So, we can also verify this communication happening from the source computer to the destination computer from our PC, where we can go to the command prompt of the computer and then running this command called netstat. By using this netstat command, it will display the various connections established from the local computer to the remote computer. So, you can see the various port numbers that are used and the various destination port numbers. You can see here HTTPS. So, HTTP and HTTPS are very commonly used port numbers. So, HTTP uses port number 80. Web requests are nothing but HTTP requests. So, let me show you. The HTTP protocol uses port number 80, and the HTTPS protocol is a secure protocol. It uses port number 443. So, this is the protocols HTTPS. So, HTTP is using port number 80, HTTPS uses port number 443, and these are coming under the reserved ports, and all reserved ports are used for the destination purpose. So, that is one of the functions of the transport layer. So, you can see the identification of service is based on port numbers, and then we have other functions like multiplexing and demultiplexing, which I will be discussing, and then we have segmentation, sequencing and reassembly, and then flow control and error correction. So, you can see that so many functions are performed at this transport layer, and that is one of the reasons why this is called as the heart of the OSI layer. So, let us look at what is happening in this multiplexing. So, when you open multiple applications like multiple browsers, browser along with FTP or Telnet, multiple application requests are coming and they are being multiplexed by the transport layer. The transport layer is responsible for multiplexing these functions. And when the request goes out of your computer and when the reply comes back, we will be using the function called demultiplexing. So, multiplexing is combining multiple streams of data into either TCP protocol or UDP protocol, and in the reverse process, when you receive data, the data comes as an input in the form of TCP or UDP, and then we have the demultiplexing, which will demultiplex and send the request to the corresponding applications. So, multiplexing and demultiplexing happens at the transport layer, and then we have, you can see the data flow from application to presentation, presentation to session, and then to transport. So, this transport layer is multiplexing these into either TCP or UDP stream, and when you receive data, they are combined into demultiplexed into TCP, UDP to different applications. So, multiplexing when you send data out, demultiplexing when you receive the data from the remote computer. So, we have the TCP and UDP applications, and they are all custom designed. I repeat, they are all custom designed. We do not have any role to play in terms of selecting the applications, whether it is TCP or UDP. It is the application developer which decides which protocol will be used or which transport protocol to be used. So, when you look at these functions or features of this protocol, TCP stands for Transmission Control Protocol, TCP. These applications which use TCP are connection oriented. There is a connection always between the source and the destination, and they are reliable because they send acknowledgements. So, when you send data, you get a confirmation that the data was delivered, and since we have to wait for the confirmation, the communication is slow, the data transfer is slow. And the protocol number reserved for the TCP applications is 6. And you can see here some of the examples of applications that use TCP. So HTTP, FTP and SMTP. In short, when we access a web page through the browser, you may be using either HTTP protocol or HTTPS protocol. So both of them use TCP application. FTP, SMTP is for email. So all this uses the internal transport protocol called TCP. And when it comes to the UDP protocol, it stands for User Datagram Protocol, and it is connectionless. Connectionless in the sense there is no communication between the source and the destination. Means like the case of the TCP, there is no established connection. So whenever you use the UDP applications, the data is sent and there is no confirmation, there is no acknowledgement for the data sent by the UDP application, and hence it is considered as unreliable because we don't have confirmation. And the reason why this application data is sent faster is because we don't have any waiting time. We do not have to wait for the acknowledgement. So the communication in the UDP applications is much faster compared to the TCP applications. Then we have the protocol number for UDP reserved as number 17. So we have a little while ago discussed about the port numbers. So port numbers are allocated by the transport layer, whereas protocol numbers are allocated by the network layer. The examples of applications that use the UDP protocol for transport are DNS, Domain Naming System, and DHCP, Dynamic Host Configuration Protocol, and then we have TFTP. Apart from this, there are other applications like, for example, video conferencing, voice over IP. All the real-time applications also depend upon this UDP protocol for data transmission. So you can see the various functions performed by the transport layer. So before we move to the network layer, let's quickly look at the functions that are performed by the transport layer. So this layer will add additional data to the header, like for example the source and destination port numbers are added, and the type of protocol, whether it is TCP or UDP protocol, are added, and the sequence number are also added to the additional information as an additional information. So when the data arrives from the application layer to presentation layer to session layer, and session layer to transport layer is adding these additional information to the received data. And this process of adding this additional information is called as encapsulation. Encapsulation is the process of adding additional information to the received data. And then we have the next layer, which is the network layer. So network layer provides end-to-end data delivery. Remember, the transport layer was only defining how the data should be sent, whether through TCP or through UDP. But network layer is one which is responsible for the data delivery. So the data delivery on the network layer is possible through two different protocols called routed protocols, which are actually called the data carriers, and then routing protocols. These routing protocols are the ones which show the path for the packet to reach the destination. And you can see the various routed protocols here: IP, IPX, AppleTalk. But among all these protocols, IP is the only protocol that is in use today. All other protocols have been outdated. They are no longer used. And under the routing protocols, we have various dynamic routing protocols called EIGRP, OSPF, RIP and BGP. So these are the various dynamic routing protocols which help the users to communicate with the corresponding destinations. So we can look at as an example that when we access internet, how does our computer know where this yahoo.com is, or where the zoomgroup.com is, or where cisco.com is. We do not know where that server exists, but we are able to communicate. How is it possible for your computer and to know where the destination is? The physical server, the yahoo.com or zoomgroup.com or google.com servers, they are available on internet, but where in internet? Whether it is in India or is it outside India? Where is the server hosted? We do not know, but we are capable of reaching that web page because of the help of this routing protocols, and that is a function of the network layer. So network layer has two kinds of protocols. They are routed protocols, and these routed protocols help to carry the data from source to destination, and the routing protocols help to show the path how to reach the destination. And the examples of network layer are hardware devices called routers. So let's have a look at how the routers will look like. So this layer controls the data communication from one network to another network, or it facilitates the communication from one network to another network. And this OSI layer network model, OSI model network layer adds the source IP, who is sending the data, and destination IP, to whom this data is being sent. And the example of the device that works at the network layer is the router. And this is the picture of the router. You can see here, these are the different categories of routers. You can see these are all Cisco routers, 3 different products available for small, medium and large organizations. And this router is also called as a layer 3 device. So this device is facilitating the communication from one network to another network. And we can see we have a small router at home. We have a router at home which is connecting from the ISP to our home, and from our smartphones and tabs and computers we are connected to this router. We call that as a Wi-Fi router. It is also a router, a layer 3 device, which is allowing us to communicate from our local network to the remote network. And then we have the next layer, which is data link layer. This is also called layer 2, and it provides error control and synchronization of the data. This is the function of the data link layer. So it provides source MAC address, means which device is sending the data, that device's MAC address, also called layer 2 address, and the destination MAC address. So for any network communication, we require 2 unique addresses called source IP address and source MAC address of one device, and to which device you want to communicate, that is destination IP address and destination MAC address. So IP address and MAC address both are necessary for data communication in the network. So without any one of these, data communication is not possible. And IP addresses are taken care by the network layer, and the MAC addresses are taken care by the data link layer. The other function of the data link layer is also for a reliable transmission of data, and that is possible with a protocol called CRC, which stands for cyclic redundancy check. The CRC protocol is responsible for ensuring that the data is reliably sent. If there is a packet damaged on the transit because of collisions or broadcast, and this packet will be removed, will not be delivered to the destination. And then the output of this layer, we call it as frame. Frame is called as a protocol data unit, and the example of this layer is called as switch. So switches that we use in our network, let us see this picture. So this is a picture of a switch, and it is called as layer 2 device. So we have seen a router which allows communication from the local network to the remote network, and this is the picture of a switch which allows the communication between the devices within our own local area network. So we have discussed about the various networking devices which were important for network communication, and the last layer of the OSI model we have is the physical layer. In the physical layer, it is only responsible for transmission of data, physical transmission or maybe wireless transmission. So, we have three different types of physical interfaces on the devices, on the PCs, computers, servers, printers, etc. We have copper wire connectivity in the form of UTP cable or STP cable, or fiber optic cable, and also wireless. These are the three different physical media that is available for connecting the various network devices in the network. And the output of this layer is called as bits. The output of this layer is called as bits. And the example of the hardware devices that are used in this model are called as hubs and repeaters. And we can actually see an example of a hub. You can see there are 4 ports available here. 4 different computers can be connected to this hub. But hub is not an intelligent device and widely not used by organizations, because it broadcasts every communication. You send data from computer A to computer B, but this device will forward this message to all other devices connected to that particular hub. Whereas switch is an intelligent device and it will send data only to the designated computer. So, it is intelligent. So, with this we complete all the 7 layers of the OSI model, and we have seen the functions of each of these layers. As a network engineer, as a systems engineer, what is important for us is the physical layer, the data link layer, and the network layer. These layers are related with network communication. And now we have the conclusion of the OSI model. We can see here on the screen the PDU, protocol data unit. So, every layer sends some information out to the next layer, and that output is mentioned as protocol data unit. So, if you see, the application layer output is data, and this data goes as input to the next layer, and when you send the data out from presentation layer, the output is data, means we are not adding new information to it, and that the data is sent to the session layer, and the output is again the data. So, the data that comes out of the session layer is going to the transport layer, and at the transport layer, remember, we are adding additional information like source port number, destination port number, etc., and we call the output as segment. So, encapsulation takes place at the transport layer, and this segment, when sent as input to the network layer, the network layer will add source IP address and destination IP address, and we call that as packet. So, the output of the network layer is packet, which goes as input to the data link layer, and in the data link layer it will add the source MAC address, the destination MAC address, the CRC values, and this output of the data link layer is called as frame. These components are very important. You must know all these protocol data units. And in the physical layer, there is no new header being added. It directly converts the frames into the bits depending upon the physical connectivity we have, either in the form of copper or fiber or in the form of wireless communication. So, this is the conclusion of the OSI model, and now we are going to look at the next model, which is